Hi, my name is Ismo Pänkäläinen and I work as an applications engineer at Spectral Measurement. And in this video, I'll give you an introduction to electroacoustic measurements using the Dscope's log-swept sine script. This is the log-swept sine script for electroacoustic measurements with the Dscope. It collects all the related Dscope features and settings into this one dialog box seen in the upper left corner. With it, you can set up the test signal and select the results that you need. The script is using the Farina method for simultaneous measurement of the frequency response and the harmonic distortion components. Here you can see the distortion impulses separate from the fundamental impulse. Next, let's take a look at the setup of the test signal and the results. The chart plays from 20 Hz to the Nyquist limit, but the amplitude, buffer size, and sampling rate can be selected. The sensitivity range defines the range over which the total SPL level and sensitivities are calculated. In the results section, you can first select to plot the harmonic distortion components up to the 8th component and the THD. In addition, you can calculate and plot the Raman bus and acoustic phase. Measuring the impedance magnitude and phase is possible by using the B channel and a series resistor. You can select also octave smoothing and its resolution. Before we run the measurement, let's take a quick look on the calibration panel. In this window, you can calibrate your microphone either with a microphone calibrator or alternatively, you can use your mic manufacturer's data. You can also define a preamp gain. Now the M1's phantom power or CCP power selection is made in the analog inputs panel of the Dscope, but it will be added here in the future. If you are doing an impedance measurement, here you can define your series resistor value. Usually this is under 0.1 ohms, and run a calibration routine using a dummy load with a known resistance value as the calibrator resistor. I've made the calibration already earlier and it is saved with the test configuration. The TTC calibration is for the tetrahedral measurement chambers, which can produce accurate and repeatable loudspeaker and microphone measurements without the use of an anechoic chamber. Shortly, we'll make a video about the LSS and TTC measurements. Now we are ready to run the test. Let's first enable the fundamental trace. You can freely select just the traces that you want to show and adjust the scaling. Let's add the second and the third harmonic. Now let's add the Raman bus. And the impedance magnitude and phase. In the LSS dialog, you can see some scalar results, like the total SPL level, the distance between the microphone and the loudspeaker, and the resonant frequency. After setting up this test and running it, you can save the configuration and the results with it. This way, you can later on load it and compare your results. Thanks for watching.